Hello everyone, welcome you all. In this videos, we are going to learn very important definitions that will help us to solve the remaining questions of the probability. This video is a very important video, and this is the actually theoretical videos. All the theory we will cover here, like what is event, what are different types of event, how what is the algebra of event, how we can find the union of two events, intersection of two events, very important. And if you have not watched the videos of SET, so first complete that videos, because now onward whatever the quality that we have learned in the class 10 is not same here, right? So we will learn up something advanced. So for that we have to very much careful this all definitions. Let us start the video. So first of all, hopefully you all know what is the meaning of event, right? So event is what actually when we are doing any random experiment, right? So whatever we want, that is our event, or whatever the things that we are talking about is our event. Let us suppose we are throwing a dice, right? And I want that the outcome is 6. So which sample point we are talking about? 6. So 6 is an event here for us. So event is nothing but that is the subset of a sample space, or you can say the event is the sample point, that is the part of sample space. So see here what is the event. So event of any set E, event is a subset, we are denoting generally E, event E of the sample space is called an event. So what is the event actually? Event is the subset of sample space. Hopefully you remember the subset. If you have not know the subset, then I recommend you to watch the set theory chapter. Okay, so this is the subset of sample space is called event, right? Let us take one examples here, that variable, let us suppose we are tossing 2 coins, right? Where we are tossing 2 coins. So whenever we are tossing 2 coins, right? 2 coins. So you know how to write the sample space for that. HH maybe, or HT maybe, or TH maybe, or TT maybe. Total the 4 sample point in the sample space. Now we can consider one by one as event. So whatever you want actually, whatever you're talking about, that point is your event. You can take any subset. Let us suppose I describe the event here. This is the sample space. We denote it as S. We can. So if we want E1 as an event, let us suppose I am describing here E1. E1 is the one event we are talking about. So here we are talking about that exactly 2 tails will become. Exactly 2 tails means we are talking about that outcomes in which 2 tail is there. So you can see how many that things are 2 tail. So only this one. So in this sample space, this is our the event here in this case. So we can suppose that A is the event here we have taken. So this is the 2 tail. If I take the next event, let us suppose that at least 1 tail. See here, these are the very important word. At least, at most, exactly, right? This is the important word. At least means you are getting the minimum limit, means this is the at least, means above this is acceptable. Similarly, at most means you are giving the upper limit, means below this is acceptable but above this is not acceptable. At most means the higher one, at least means the lower one. So if it is given here the number of tail is at least 1. At least 1 means here 2 tail is also acceptable. So in this case this will work, this will work, and if 2 tail is there, then no problem, because at least condition is on at least. So this is HT maybe, or TH maybe, or TT maybe. So this is the sample. This is here the our events, right? If we're talking about this event in which at least 1 tail is coming. Next, even let us suppose here C, and what is here, that at most one head, at most one head means at most more than one head is not acceptable. Yes, less than one head is acceptable, means at most one head. So this case will not be considered because here two head is there. This is considered, yes, because one head is only. This is also acceptable. This tail case is acceptable, yes, because at most one head is given. So this is also acceptable. There is no head in it, so it is acceptable because at most limit is on upper side, right? So two head is not acceptable, but less than two head is acceptable, right? At most, one head means head, tail is acceptable, tail, head is acceptable, and if no head is there, then also acceptable, right? So this is the this events here. Next, D, if we're talking about second toss is not head, right? Second toss is not head, right? So we have to focus on the second. That should not be head. Means second must be tail only. So let us put our second part is tail. And any condition on the first? No. So first may be head or it may be tail. So that th or tt may be the case. Why not this? Because second is here head. Why not this? Because second is here head. So this we can't consider because question already said that the second outcome should not be the head. So this is the here event for this case. Similarly, tail is at most two. Now see, at most two tail. At most two tail is this one. One tail considered, yes, okay. One tail, no tail also considered because we are talking about the at most two tail. So more than two tail is not acceptable, but up to two tail is acceptable. So here actually all is coming in this situation. If the question if we make the event that the tail is more than 2, so we all know that when we are tossing two coin, so maximum two tail we get not more than 2. So what is the here in this case, that is the 5, means no uh, such any outcomes in which more than 2 tail be there. Got it? So in this way actually we have to do this. Okay or not? So next one here is the types of event, right? So events can be classified. Event can be classified into two various types on the basis of elements they have. Okay. So this is the main classification. One is the impossible and one is the sure event. Its name clearly, its meaning is clear. Impossible means that events that can't be happen. Let us suppose we are tossing a coin, right? So when we are tossing a coin, and if we're talking about what is the probability or what an event in this outcome, so let us suppose to be 5. So let us suppose events that outcomes is 5, events in which outcomes is 5, outcomes coming 5. So it is impossible because when you are tossing a coin, so either head or tail you will get. But you are considering an event in which outcomes is 5, so it is impossible. So those events whose probability is 0 or there is empty, no element in that event is called empty, is called an impossible event. So the empty set 5, right, of the sample space described as the event is called impossible event. So here 5 is called what? Impossible event. Okay. And what's the sure event? The whole sample space is called as the sure event. So what is the sure event? The whole sample space is called, means one belief you will get. Let us suppose, for examples, the same example I am taking here, the tossing a coin, right? So tossing a coin. So when you are tossing a coin, either you get head or you are getting tail. Now let us suppose I am making an event E that outcomes 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 is either either head or tail, either head or tail. Now tell me here, what will be the in this case the probability? 100%, because either when you are tossing a coin, so either we will get head or we will get tail. This is the sure event, right? So means this actually we have written all the simple space here. So in this case it will be the sure event. Means in sure event, the total simple space if we take in the subset, that will be the sure event. Impossible event means if we take the empty subset from the sample space, or there is no point in the event, is called as the impossible. And if all the sample space are present in your event, that is the sure event. So hopefully impossible and sure is you got the concept. Let us suppose I am telling, let us take one more example, tossing a die or throwing a dice, and I am saying what is the probability that 20 will come. Now whenever you are throwing a dice, right? Whenever throwing a dice, throwing a dice. So outcomes may be either 1, 2, 3, 4, 5 or 6. But I want that the outcomes is 20. So it is impossible, it is not possible when you are throwing a dice. So either you get 1 to 6 any number, but you can't get 20. Similarly, if I'm saying if we are throwing a dice, so what is the probability that number will come from 1 to 6? So it will be sure when you are throwing a dice, so number will be 1 to 6, or I can say what is the probability that number is less than 6, so less than 7. So if I take if I am saying less than 7, so all the number 1 to 6 are considering in that is again sure event. So in sure event, all your sample space will be there, simple concept. And in possible event, no sample point or no any element of sample point is there. That is the empty subset. Okay, so hopefully impossible and sure event is clear. Now the next here we have the simple event, right? So what is the, as mentioned, simple event? Okay, so whatever the sample space you have, and if you are taking any one sample point from there, or any one element of the sample point, then that sample space is called as a simple event, right? So if an event E has only one sample point of sample space, right, it is called as the simple event or elementary events, right? So if there is only one sample point, if we taking, then that is what? That is the simple event. So in a simple space containing n distinct element, there are exactly n simple events, right? For example, let us suppose taking one example. So tossing two coin, right? If we are tossing two coin, then simple space, head or head tail, or tail head or tail will we can get. Let us suppose, so what is the here a simple event maybe? So let us suppose A may be the simple event in which both are showing here head. So this is the one of the simple event. Let us suppose B is the event in which the first coin is showing head, second coin is showing tail. This is the simple event. Or you can take C is another event you can make in which first coin showing tail, second coin showing head. Or we can take the another event D in which both coin showing tail. So in this case actually simple event. Or let us suppose one more example take. Here we are throwing a die, right? Throwing a die, right? If we are throwing a die, so what is the sample space? We all know that is 1, 2, 3, 4, 5, 6. Okay, so if I am saying here A is a event in which outcomes is 3. Let us suppose A is an event event in which outcomes outcomes is 3. Outcomes is 3. So okay, so only one case here, in which outcomes is 3, that one. So this is a simple event. Simple event is simply in which only one sample point we have to take. So here how many sample point? 1, 2, 3, 4, 5, 6, 4, 6 sample point. Here what is the sample point number 1, sample point number 2, sample point number 3, sample point number 4. So in this case here we have to put 4 sample point. Got it now? So in the sample space, how many the elements, that is called as the sample point. So hopefully simple event is clear to you. Fine. Okay. So next one is what? Compound event, right? So what is the compound event here? So if an event has more than one sample point, right? So in the simple event, only one sample point, but here having more than one simple point is called a compound events, right? So if an event having more than one sample point is called the compound event. Let's take one example. So whenever we are here tossing three coins, right? So here what we are doing, tossing three coins. So let us first write the simple space in this case. When we are tossing three coins, what is the simple space? Head, 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 or head, head, tail, or head, tail, head, or here may be tail, head, head, or it may be tail, tail, head, or it may be like tail, head, tail, or it may be head, tail, tail. Okay, or all three can be tail. So total 8 sample point, and let us count 1, 2, 3, 4, 5, 6, 7, 8. Yes, total 8 sample point, right? Now see here we have made one event E in which exactly one head appeared, right? So we have to consider all those outcomes in which exactly one head appeared. So you can see this is the one case in which one head is there. This is also one case, one head is there. This is also one case in which one head is there. So this all three will be considered as our element of our this outcomes. That is, you can say your event. So what is the elements here? That is T, T, H. One more is T, H, T, and one more is here H, T, T. So you can see here how many simple points are there in this event? 3. So that is called as a compound. Means here more than one simple points are there. Similarly, if we consider this second example, here are considering if as an event in which at least one head appeared. Now hopefully you got the concept of one head. So see, here you have F as an event in which at least one head, right? So at least one head means more than one head will be considered as our favorable case. Means here you can see all the cases will come except this one, right? So this will be your considered yes, because at least one. So more than one will also be counted. So at least one head. So H H H H H T H T H T H H here, okay, here, and T T H. After that this is also okay, T H T and H T T. So this all are your this one. So this is what actually the compound event. Why compound event? To be more than one sample points are there. Here how many sample point? Total 7. So this is compound event. Similarly, let us write this G also. So G is here what? At most one head appeared, means maximum one head. So here what are the case actually? At most one head means this case and all this second case also we have to remove. So this may be there that T means no head, it's acceptable. One head also acceptable. You can write H T T T H T T T H, but this 4 cannot be can take. Why? Because here 2 heads are there. In this case 3 heads are there. So in this it's written at most one head. So means maximum we can take one head. More than one head not acceptable. So hopefully you get the concept of compound event. Fine.